All right, I want to thank everybody for joining us for today's webinar entitled Accelerating Data Integration Through Tech Enablement. This is presented by our friends at Scitara and brought to you by Asterix. We're going to go ahead and get kicked off here, but before we go into the actual meat of the presentation today, not sure if you've participated in any of the webinars that we've been putting on directly and with great partners like Scitara. If not, we'll give you a brief overview of who Asterix is, and then we'll hand it to the capable hands of Dave, our speaker for today. So for over 25 years, our unique breadth of highly specialized services, processes, and technology has enabled Asterix to be a leading partner in transforming the ways science-based businesses succeed. We are a professional services company that services the life sciences sector. A couple of fast facts: we were established in 1995. We work with a lot of different vendors in the space for a variety of different types of technologies. Scitara, including, would be one of those partners. We operate from locations throughout the United States and overseas, and we have 1,200 employees. 90% of our team members hold advanced scientific degrees, so we are truly a science-based company. Headquarters are in Red Bank, New Jersey, and the clients we serve are going to be startups to Fortune 1000s, mostly life science enterprise, but we do also service chemical, CPG, government agencies, and research institutions. In terms of the spectrum of services, we support the continuum of scientific operations and data management, and this is going to, encompass a wide array of areas, everything from strategic innovation and roadmaps through enterprise architecture. In those types of services, it's obviously a lot of strategy involved with those, but then also trying to help organizations figure out, what technology they need, to bring their laboratory into the digital age. We also assist with governance, and data management. This is going to be implementing strategies, methods, frameworks to make sure that digital assets and data integrity are rock solid. We do business analysis, ensuring people, process, and technology are optimized to transform end-to-end workflows and data incorporating organizational change management. Solution selection. We can help you pick the right tools based on the work we've done up to that point. We can help with development and implementation and validation of those services and systems. And of course, we can also provide direct staffing, so scientific staffing as well as technical staffing, to help you on an ongoing basis. So with that, enough about Asterix. Let's talk a little bit about Scitara and a little bit about our speaker for today, Dave Levy. He's the head of strategy, partner management at Scitara Corporation. Dave brings over 30 years of product management, global account experience at leading technology companies like Waters, New Genesis Technologies, Cambridge Soft, and PerkinElmer. He has an MS in geology from the University of South Carolina and a BS from the University of Louisville. So with that, Dave, I'll go ahead and pass it over to you. If you just give me a little next slide as we're going through the presentation, I'll make sure we keep on track.
Thank you very much, Kevin. And greetings to everyone who's tuned in today. Very much appreciate folks taking time out of their busy schedules. So we want to talk a little bit today with you about both a combination of technology and a concept that we've been talking with our partners at Asterix about called tech enablement. So we're going to share a little bit with you about Scitara, about the Scitara Scientific Integration Platform, and then a little bit about some of the dynamics and implementation strategies that can be used to accelerate data integration using a combination of technologies and leveraging relationships with partners like our good friends at Asterix. So Kevin, if you go ahead and advance the screen. So we hope that during the course of today's webinar, as you come out of it, you'll have a few additional new things to think about. Certainly, looking at lab integration in a very different way. One of the key things we want to talk about is the ability to accelerate the pace of systems and lab integration, and of course, future-proof your lab, coming up with technologies and strategies that allow you to adapt to changing business needs as well as changing instrument and software technologies in the lab. Next slide, please, Kevin. All right, so let's start with kind of an introduction to the Scientific Integration Platform, or SIP as we call it. So the Scitara Scientific Integration Platform is really focused on a new concept from our perspective called data mobility. Data integration or data aggregation is a key component of what, and a key factor and focus of what many companies are driving to today. And you see data aggregation coming about in applications like e-notebooks and LIMS and data lakes. However, what we're finding is that the real path to data aggregation and what's holding data aggregation back really is the lack of data mobility. That specific area is a focus of Scitara and what the scientific systems integration platform is all about. So the goal is really to provide the ability to automate the exchange of digital data between all of the endpoints in the laboratory in a fully integrated environment. And that includes informatics applications. It includes benchtop instruments like balances, pH meters, PC-based instruments, file exchange. It's really wrapping our arms around that entire ecosystem and creating a flexible environment that really puts the power into our customers and our partners' hands to be able to modify and change the business rules and the framework of how those integrations exchange information. We believe that this will dramatically accelerate the sharing of scientific data across the enterprise and really promote and drive data aggregation. And we're seeing this already with customers and partners alike. Next slide, please, Kevin. Keep moving. Oh. One more, please. So go ahead, Kevin, and advance the slide twice. One more, please. Okay, stop there for the moment. So if you think about the way that systems integrate in the laboratory today, and have been for many years, in fact, things really haven't changed much over the past 30 years, quite honestly. As software and instrumentation has improved dramatically, the way these different assets talk to each other really hasn't changed much at all. There's plenty of opportunities for web services and custom developments. And this is part of the problem that we're trying to overcome. These integrations, while they may work, tend to be very specific. They are hardwired most of the time. They're not very flexible in terms of making changes. They break easily, for example, when new versions come out. And it creates, even as an independent integration, it's just challenging to manage over time. Kevin, go ahead and hit the next, and this will build automatically, or it should. Now, if you take that problem and you expand it to include all of the different integration needs that you find in a typical laboratory, the situation very quickly becomes just untenable. And we've had partners and customers alike share this with us and agree that this is just not a viable way to manage a laboratory. And there's no way that you will ever be able to really cover all of the different integration types and styles in a lab. So Scitara, instead of trying to refine or polish this approach, we've taken a completely new tack on this challenge. And please advance the slide. And hit one more. There we go, perfect. So the first step really is eliminating the point-to-point concept entirely and creating an infrastructure that supports what we call peer-to-peer communication. So we are building out commercial connectors for all of these different endpoints. Some of them, there's a variety of different kinds of connectors. We're going to get into that in a little while. But all of these connectors, when they plug into the Scitara infrastructure, they publish their presence, and they also publish what they can do. And all of the other connectors in the system that are plugged in, they can all see each other. And next slide, please, or next advance. And what this does is it creates a configurable environment using a technology we call orchestrations, which we'll talk a little bit about in a moment, that allows configurable access to all of these and configurable design of business rules to drive the flow of information across all of the endpoints. So instead of being point to point, it really can be many to many, and data can freely flow between any of the endpoints. So this is a key component of this underlying technology. There are really three primary elements to the Scitara DLX platform. Next slide, please, Kevin. One more, please. Sorry. There we go. So the three elements are connect, orchestrate, and monitor. So there's a number of different types of connectors that Scitara has put together. There are connectors that support simple devices. This would be anything without a computer attached, like a balance pH meter, for example. These are typically managed with a small IoT device that we provide. Scitara provides it. It's provisioned with our software. It's a small Linux box. It plugs into the instrument with an RS-232 cable, although there are other integrations available. And this is what gives the Scitara platform the ability to communicate with these benchtop devices that typically do not have very often a direct communication. If they do have a direct communication, very often it's just a direct interface into a network where all that the receiving application can do is listen for that particular device to broadcast a weight or a pH reading, for example. Using the Scitara technology, we can actually, you can send the device commands, you can receive information back, you can require credentials. It creates a much broader, more effective framework for interfacing and managing simple devices in the lab. Instrument applications are applications that are PC-based, and this can range from enterprise-class applications like some of the higher-end chromatography data systems to standalone instruments that have one PC per instrument in the laboratory. Anything that has a PC. And for these applications, we typically download a small connector onto the computer. It is configured and that connects with our platform, and that's how we interact with that particular system. Informatics systems would encompass things like LIMS, e-notebooks, MES. These are very often web service-based systems. In this case, there is no download required. Really, it's just a configuration with appropriate credentials to access the necessary resources. And then finally, we spike out web services separately because there are a number of web services scientists typically use in the lab that are business related. Office OneDrive, for example, Office 365 OneDrive, or now it's Microsoft 365 OneDrive. Excel, for example, Google Sheets, Google Drive, Box. These are all tools that scientists use in the lab from time to time. And we do have connectors that support those, as well as a generic Windows file connector that can be downloaded on a PC and monitor Windows folders. Now, having connected all the endpoints together, as I mentioned before, it's the orchestration engine that really drives the power of automation. And orchestrations have triggers. These are all user editable. And that's what I was referring to when I said we want to put the power back into the hands of our partners and our customers, where if you want to create an orchestration that controls the flow of information between a LIMS and a CDS, for example, or a balance and a CDS, or a balance and a LIMS or an e-notebook, that is something that with appropriate training, anyone that has our platform can do. Orchestrations are editable with appropriate privilege, and they can be modified over time as your business needs or as your technologies change. As I mentioned, orchestrations have triggers. They can be triggered based on a timer. You can set up orchestrations to run automatically every 5-10 minutes, every day, once an hour. You can set up orchestrations to be totally manual, or most effectively, you can set up orchestrations to be event-driven. And in this case, part of what our goal is with our partners is to integrate so seamlessly into our partners' infrastructure that, quite honestly, the end users in the laboratory may not even know Scitara is there. So if you want to send, for example, a request to a balance for a weight measurement from an e-notebook, we will configure with our partner and this is fully, again, user editable, but we will configure with our partner a button in the e-notebook or a link that when that button is clicked, it triggers an event in our system, which then allows a workflow to commence that could involve user notification. For example, sending users a notification that a sequence or a sample set might be available in a chromatography system, or that balance weight I just mentioned is a request has been made and that somebody needs to go take a balance weight, or for example, to review data on the other side as results are coming out of equipment. If you want somebody to take a look at it before it reaches its destination, you can do that as well. So The ideal scenario here is as much automation as your lab is comfortable with, and that can be put together through a combination of event-driven workflows, user and group notification, as well as we support business logic for data in flight. So this includes the ability to reformat data so that it's in the right shape when it reaches its destination. If you need to do calculations, whether it's changing something as simple as changing units, for example, or even more sophisticated calculations, that can be done as part of an orchestration. And really, this drives automated data exchange between orchestrations and connections in the laboratory. Now, on the monitoring side, there's a couple of areas that are important to spike out. One of them is the ability to monitor what we call an event stream. So we do not consider ourselves a repository. Our goal, as I said, with data aggregation is to feed your repositories, to let you define what repositories you need data in, and to provide high quality automated data entry into those repositories. But we do, for purposes of data integrity and compliance, we do track the flow of information through the Scitara system, and that's captured in the event stream. So inside of the event stream, we have all of the information that flows through Scitara Digital Lab Exchange in context with all of the metadata that was captured, and it is possible to reconstruct the entire flow of an orchestration, whether a few minutes after it executes or a few years after it executes. All of that data is immutable in our system. In addition to that, we do have an online orchestration monitor, and this allows lab managers to watch and observe the flow of data in the lab in real time. So you can actually watch orchestrations execute on the fly as they move forward. Aside from lab managers and our colleagues and partners on the IT side, whether they are partners like Asterix or in your own organization, no one else should ever need to come to the Scitara Digital Lab Exchange web console. As I mentioned before, for the folks in the lab that are actually running the instruments on a day in and day out basis, our goal is to basically become infrastructure and to not necessarily play a prominent role from a user interface point of view. Next slide, please. So what does this mean for our customers that are deploying Scitara Digital Lab Exchange in their laboratories today? First, it allows you to get an element of future proofing into your laboratory. It becomes much easier to add new technologies into the mix, retire old technologies, or make changes to workflows as needed. So there's an opportunity now to basically look at really best of breed and not worry so much about having to purchase particular pieces of equipment simply because there's an integration that's already built in with a particular informatics platform, shall we say. On the orchestration side, we really want to, as I said, put the power back into your hands and increase your flexibility. So while we do have a professional services organization at Scitara and we work with our partners at Asterix, the goal here is really to give the flexibility and the capability to easily make changes to the system because business needs change. New technologies come into the lab, old technologies get required. Orchestrations give you the ability to leverage automation to the extent that you're comfortable with. I don't think anybody is necessarily all that comfortable with completely automating everything and removing the ability for people to actually review and approve certain elements of data before they go into their final location. So the flexibility is there that allows you to automate to the extent that you're comfortable. And certainly mixing and matching connected systems and workflows, that as you build out these orchestrations, if you find that you have another orchestration in an adjacent laboratory, let's say, that has 60% overlap with one that you've already built, then you can easily basically do a save as function, give that orchestration a new name, change the connectors in and out through a just user selectable user interface, make the changes to the orchestration that you need, and test it out and keep moving. And And you can do all this in a regulated and compliant environment. The Scitara scientific integration platform and the underlying digital lab exchange technology have been fully, have a full software development lifecycle. They were developed in with a software quality management system. We've been audited in the past. We're expecting to be audited again. And the software is designed for use in a regulated environment, although it works very well in an R&D environment as well. Next slide, please. All right, so let's take a little bit and talk about some practicalities. And this is really where a lot of the tech enablement comes into the picture. Historically, when you've thought about putting an integration together between, let's say, an informatics system and an instrument of any kind, there's quite a lot of effort that goes into that, because most of these types of integrations tend to be custom, and they require a lot of effort to spec out the requirements, to identify somebody to actually write the integration. Very often, that's, as I said, it's custom code. It's very often hardwired. Our goal with the digital lab exchange and the overall platform is to leave that world behind entirely and to replace it with commercial tools that can be assembled like building blocks. And when combined with partners like our good friends at Asterisk that really understand the nature of your work, that understand the workflows that are going on in your lab and the challenges that you've had before, it allows for a tremendous acceleration in the ability to build out these integrations and actually get productivity out of them. So as a start, let's talk a little bit about connectors. So we have a number of different connector technologies available that really drive a lot of out-of-the-box coverage. We've made a commitment at Scitara to effectively integrate to virtually everything you have in the lab that needs connecting to. Part of our motto is no instrument or application left behind. If there's a need for you to integrate an instrument or an application, we will find a way to do it. And we've built out a team and a set of technologies that allow us to do this very rapidly. So for example, this is some examples of some of the different kinds of technologies that are available. Certainly the most seamless and have the best user experience type connectors are API based. And there are a number of applications out there that have very rich APIs that are publicly available that we've been able to use. And those APIs allow for very seamless connectivity where we can configure those buttons, we can configure the links. So part of our connector, when we create a connector for a given application, if that connector is API based, those tend to have the best user experience of all the connectors that we build. We take responsibility for managing those connectors. As being responsible for partner management, we also take a very serious responsibility in developing relationships with all of our vendor partners, not just from the standpoint of understanding what it takes to build out the connector, but also to build a long-standing relationship to support them in their integration needs as well, and to make sure that we stay up to date with new capabilities that are coming out and update the connectors as needed for when versions change. So I'm going to skip down one to DLX file exchange. So there's still many, many applications out there. In fact, quite honestly, the majority of applications don't have APIs. They basically still work on files. And so we have a very robust and have developed and continue to develop an increasingly robust file exchange mechanism, whereby we can, through both a combination of either Box, I wanted to start with Windows File Connector, Box, Microsoft Office 365, OneDrive. All of these support the ability to watch for files, to configure folders to watch for files. And when those files drop into those folders, based on certain trigger conditions, which we can set up, we can automatically process or reformat or perform other functions on those files. But it's also possible, because it is a two-way street, right? What we're working to do is to effectively create an environment where your instruments and your informatics systems are having a dialogue with each other. They're actually talking to each other in a bidirectional way. So from a system like an ELN, for example, a file could get dropped into a folder from an instrument that doesn't support an API, that could trigger a notification to the user team that this file is now available. And instead of doing it automatically, you could navigate to that file through a button inside of your eNotebook and select it and parse it and bring it into your eNotebook interactively. So we support both of those dynamics. The key is that for the broad range of equipments that are file-based, we have a very solid and very capable solution. For the simple devices or the non-PC based instruments like the balances, pH meters, etc., we have an IoT based connector, as I mentioned. This is say a 3-inch by 2-inch by 1-inch deep small device. It's basically a black box. It can connect to wired Ethernet, or supports Wi-Fi as well. Connects to the instrument, as I mentioned, through RS-232, but capabilities for Bluetooth and other connectivities and USB are also there. This device is provisioned with Scitara software and can establish a connection to the balance or the pH meter, and allows you to interact with it through our software. So you can either directly interact with it by, again, clicking a button inside of a notebook or a LIMS. You can send asynchronous requests. So if there's a generic request for a balance weight, and there could be any one of a number of people who could fulfill that request, it's possible to support that as well. On the web service side, there are a number of different kinds of APIs, as you might imagine. There are traditional APIs that are on PCs like .NET, things like that. But then there's also web service APIs also, and many of those we use for our informatics partners. So for many of the leading eNotebooks, we support a direct API-based connection, and that allows for a very seamless and excellent user experience within those packages. There are a lot of other services out there, web services out there, however, and many of them are homegrown, actually, in customer environments. And so we have a generic web service connector that is fully configurable. It's very similar in concept to the file connector, which can really take on pretty much any human readable file. The web service connector can communicate with any web service as long as it has a few basic supporting functionalities, like it supports gets and puts, and even authentication if the authentication is encoded into the URL. So there's a lot of flexibility there in addressing generic web services and bringing them into the Scitara infrastructure. And then finally, there's an opportunity to explore what we call manual connectors, or a universal connector. There are instruments out there that simply don't have any connectivity. This could even include the need to read a dial on a wall or on the side of an instrument. We're doing a lot of work in the bioprocess space, for example, with bioreactors. And although a lot of information can be provided through OPC, which we also have a connector for, there are scenarios, and we've had people tell us about situations where there's a reading on the side of a machine somewhere, and they just want to be able to go up and capture that reading. Or if you had a pH meter, let's say, that just had no connectivity at all. So it is possible to configure a manual connector that you configure to take readings of a specific type, that you can even put boundaries on the available entries that can be put in. And for these types of connectors, as well as for the IoT-based connectors, it's possible to add comments and even take a picture and insert those into the event stream. So wrapping up on this particular topic, an important consideration here is that, as I mentioned before, all of these are part of our commercial product. They are not custom designed. If we're building new connectors all the time, but when we build them, they go into our connector library, and all of our customers have access to the full connector library. And so everybody benefits as we add new technologies along the way. So to add a new connector or configure a connector, there is a standard process within Scitara DLX that is documented, and that IT folks and lab managers can use to bring new connectors online. Next slide, please. So I want to talk a little bit about orchestration. So I've just got a couple more slides, and then we'll open up the floor for questions. Orchestrations really are, in my personal opinion, the magic of the Scitara platform. Because what orchestrations do is give you a user editable capability to define automation, define the business rules, and create those workflows, and then watch them as they occur, right? And track the data that flows as a result. So what you're looking at on the right-hand side is an example of the orchestration editor. This is part of the Scitara platform. As with any enterprise platform, there's a standard user group role capability within Scitara DLX, and if you have the rights to edit or create orchestrations, then you can do so. And as you can see on the screen, orchestrations really are a series of steps. And all orchestrations will start with a trigger. And then you basically select from a list the different connections that you want to interact with, and then you configure those connections as you see fit, because the connections again publish all the things that they can do. The function transform step, which you see as the second step there, is the step where we provide the ability to reshape data, or change the data format, or do calculations, if you will. This is typically done with JavaScript, but if you have, you don't have to necessarily know the details, the ins and outs of JavaScript, because if you have certain routines that you're going to do over and over again, then once those routines are completed, they can be packaged in what's called our transform library, and selected, where all the orchestration editor needs to do is simply select the inputs and the outputs. And the rest of it is all handled internally. So this allows you to construct multi-destination data flows. You can communicate with multiple applications in one orchestration. And it gives you a tremendous amount of ability to really drive the decision-making process by making data more accessible and more available. Next slide, please. So I think this is the last slide, if I'm not mistaken. And I just wanted to give you a sense of, to wrap up, a couple things. I mentioned that it's possible for a lab manager or someone to watch orchestrations in flight as they're executing. And what you're looking at on the screen is an example of that. It is also possible, as I mentioned, to share notifications and to look at the payloads of data as they flow through the system. So as you see that you can expand the orchestrations, the top one is expanded. This is an orchestration that's already executed. And if you click the down arrow, you can see the little green down arrow in any one of those steps. It's possible to actually look at the full payload. You can see what the orchestration, what that step in the orchestration took in at the beginning and what data went out on the other end. It is also possible within orchestrations to visually see when orchestrations fail, because things do fail from time to time. And when an orchestration does fail, the system will give you the ability to inspect that and identify what failed, so you can go back and fix it. So with that, I think, next slide, please. With that, I want to thank everyone again for their time today. It's been a pleasure chatting with you. I'm very open to take questions, but I hope this has been useful, and I hope that you've enjoyed the last half an hour, 40 minutes or so. Thank you very much for your time.
Dave, thank you very much, and appreciate the flexibility in adapting to the slide snafus there in the beginning. I think we got through that fairly smooth. We're going to go ahead and stop the recording. So let me just